Now the topic is multi-core processor. I am Get Billy from France. Till recently, the approach used for building faster processor was to keep reducing the size of chip while increasing the number of transistors they contain. Although this trend has driven computing industry for several years, it has now been realized that transistor cannot shrink forever. Current transistor technologies limits the ability to continue making single core processors more powerful due to the following reasons. First, as transistor gets smaller, the gate which switches the electricity on and off gets thinner and less able to block flow of electrons. Thus, a smaller transistor tends to use electricity all the time even when they are not switching. This wastes power. Second, increasing clock speeds causes transistor to switch faster and generate more heat and consume more power. These and other challenges forced processor manufacturers to research for new approach for building faster processor. In response, manufacturers came out with the idea of building multi-core processor chip instead of increasingly powerful, faster single-core processor chips. That is, in the new architecture, a processor chip has multiple cooler running, more energy efficient processing cores instead of one increasingly powerful core. The multi-core chips do not necessarily run as fast as the highest performing single core models, but they improve overall performance by handling more work in parallel. For instance, a dual core chip running multiple applications is about 1.5 times faster than a chip with just one comparable core. We know that operating system controls overall assignment of tasks in a multi-core processor. In multi-core processor, each core has its independent cache, though in some design all cores share the same cache, thus providing the OS with sufficient resources to handle multiple applications in parallel. When a single core chip runs multiple programs, the OS assigns time slice to work on one program and then assign different time slices for other programs. This can cause conflicts, errors, or slowdowns when the processor must perform multiple tasks simultaneously. However, a multi-core chip can run multiple programs at the same time, with each core handling a separate program. The same logic holds for running multiple threads of multi-threaded application at the same time on a multi-core chip, with each core handling a separate thread. Based on this, either the operating system or a multi-threaded application parcels out work to multiple cores. Multi-core processors have following advantages over single-core processors. They enable building of computer with better overall system performance by handling more work in parallel. Second, for comparable performance, multi-core chips consumes less power and generate less heat than single core chips. Hence, multi-core technology is also referred to as energy efficient or power aware processor technology. Third, because the chips cores are on the same die, in case of multi-core processor architecture, they can share architectural components such as memory elements and memory management. They thus have fewer components and lower costs than system running multiple chips. Next, also a signaling between cores can be faster and use less electricity than on multiple chip system. Now multi-core processor, however, currently have following limitations. We see the limitations of multi-core processors. First, to take advantage of multi-core chips, we must redesign applications so that processor can run them as multiple threads. Note that it is more challenging to create software that is multi-threaded. Next, second point is that to redesign application, programmer must find good places to break up the application. Divide the work into roughly equal pieces that can run at the same time and determine the best times for the threads to communicate with one another. All these add to extra work for programmers. Now the third point is that software vendors often charge customer for each processor that will run the software. That is one software license for per processor. A customer running an application on a 8 processor machine, that is multi-processor computer with single core processor, would thus pay for 8 licenses. A key issue with multi-core chips is whether software vendors should consider a processor to be a single core or an entire chip. Currently, different vendors have different views regarding this issue. Some consider a processor as a unit that plugs into a single socket on the motherboard, regardless of whether it has one or more cores. Hence, a single software license is sufficient for multi-core chip. On the other hand, others charge more to use their software on multi-core chips for pre-processor licensing. They are in this opinion that customers get added performance benefit by running the software on a chip with multiple cores, so they should pay more. Multi-core chip makers are concerned that this type of non-uniform policy will hurt their product sales. Chip makers like Intel, AMD, IBM and Sun have already introduced multi-core chips for servers, desktop and laptop. The current multi-core chips are dual core, 2 core per chips, and quad core, 4 cores per chip, or 8 cores chips and 16 core per chips. Industry experts predict that multi-core processors will be useful immediately in server class machine but won't be very useful on the desktop system until software vendors develop considerably more multi-threaded software. Until this occurs, single core chips will continue to be used. Also, since single core chips are inexpensive to manufacture, they will continue to be popular for low price PCs for a while. Now, power efficient processor. Traditionally, a system performance was measured in terms of its processing power. Now, however, excessive power consumption by computing system has now become a matter of concern for most organizations. Cost of operating computing system often far exceeds cost of purchasing them. Hence, considering total cost of ownership (TCO), a new measure that has become popular for measuring performance of a computing system is power consumption to processing power ratio. Manufacturers of computing systems have therefore made attempts at all levels in computer architecture to reduce power consumption of system. Processor manufacturers have come out with new processor architectures to reduce power consumption right at processor level. For example, the latest Intel Xeon processor offers a technology called demand-based switching (DBS), demand-based switching (DBS), for reduced power consumption. A traditional processor operates only at a single frequency and voltage, regardless of its workload. Therefore, it is always on and always consume full power. Processor based on DBS technology, demand-based switching technology, are designed to run at multiple frequency and voltage settings in conjunction with an operating system and basic input-output system (DIOS) that support demand-based switching. Such processors automatically switch to and operate at the lowest setting that is consistent with optimal application performance. The OS monitors processor utilization multiple times per second and upshifts to a lower, higher frequency and voltage as appropriate. Therefore, power usage is automatically tailored to match dynamically changing system workload, which substantially reduces power wastage and with minimal impact on peak performance capabilities of the processor.